March 7, 1945, 3:47 p.m. The west bank of the Rhine River, near Remagen, Germany. The river runs dark and swift, swollen with spring melt from the Alps, carrying with it the debris of a collapsing empire, shattered timbers, abandoned equipment, the detritus of retreat. The air smells of cordite and wet stone, of the acrid smoke that drifts from burning vehicles on the far shore. Artillery rumbles in the distance, a constant percussion that has become the heartbeat of this advance. On the west bank, near the small town of Remagen, American soldiers of the 9th Armored Division have achieved something that High Command thought impossible. They have captured the Ludendorff Bridge intact, the last standing bridge across the Rhine, the final natural barrier protecting the German heartland. The bridge itself is a massive iron structure, built during the First World War, its lattice steel trusses rising like a cathedral over the swift current. But it is damaged, scarred by German demolition attempts that partially succeeded, and it trembles with every vehicle that crosses. Engineers estimate it can collapse at any moment. Behind the American lines, 3 miles back from the riverbank, Lieutenant Colonel Harvey Fraser of the 291st Engineer Combat Battalion receives orders that seem to defy reason. His battalion is to construct a tactical bridge across the Rhine, a full military span capable of bearing 60-ton tanks, to be built parallel to the damaged Ludendorff Bridge as a contingency. The bridge must be 1,200 feet long, spanning from the west bank to an island in the middle of the river, then another section from the island to the east bank. It must be built while under direct observation by German artillery on the heights across the river, while German snipers still hold positions in the ruins of Remagen, while the entire bridgehead remains under threat of counterattack. And it must be completed as quickly as possible because the damaged Ludendorff Bridge could fail at any hour, cutting off the American forces already across the Rhine, trapping thousands of men on the east bank with their backs to the river. Fraser looks at the river, at the swift current running at 8 knots, at the German-held heights on the far shore, at the impossibility of what he has been asked to do. Then he orders his men to bring up the pontoons. In the months and years before this moment, German military engineers have been regarded as among the best in the world. This is the nation that built the Autobahn, the sophisticated network of military highways that allowed rapid mechanized movement across the Reich. This is the Wehrmacht that pioneered blitzkrieg tactics, coordinating infantry, armor, and air support with a precision that overran Poland in weeks, France in 6 weeks, pushed to the gates of Moscow in 6 months. German engineering is synonymous with quality, with thoroughness, with the kind of methodical excellence that produces Panzer tanks, U-boats, and the V-2 rocket. German pontoon bridges, built by the Pioneer Truppen. The Pioneer troops are efficient, reliable, carefully designed for rapid deployment and durability. A German engineering battalion can construct a tactical bridge in a day or 2 under ideal conditions, perhaps faster if pressed, though always with attention to proper procedure, to doing things correctly rather than merely quickly. The American engineers arriving at the Rhine are different products of a different philosophy, a different culture. Many of them are not professional soldiers, but civilians in uniform. Construction workers, iron workers, loggers, men who built highways and dams and bridges across the American landscape during the Depression, who learned their trade on projects like the Hoover Dam and the Golden Gate Bridge, massive undertakings that required innovation, speed, and a willingness to take risks. American military engineering doctrine emphasizes rapidity and adaptability over perfection. The standard is good enough to get the job done, not built to last forever. This is partly necessity. The U.S. Army is building bridges, roads, and airfields across Europe at a pace that would be impossible if every structure required German-level precision. But it is also philosophy. American engineers are trained to improvise, to make do with available materials, to find quick solutions rather than optimal ones. The manual for the M2 Treadway Bridge, the system Fraser's battalion will use, is thick with specifications, but the actual training emphasizes speed drills, competition between units to see who can assemble sections fastest, a culture where beating the clock is as important as following every regulation. The Rhine crossing at Remagen is the culmination of this cultural difference, the moment when two approaches to military engineering come into direct, visible contrast. The German defenders, looking down from the heights of the Erpeler Lay across the river, expect the Americans to follow conventional doctrine, secure the bridgehead, establish supply lines, bring up heavy equipment, survey the river, prepare foundations, and then, perhaps in a week or two, begin construction of a proper bridge. This is how serious river crossings are done. The Rhine is not some minor stream, but a major European waterway, 400 yards wide at Remagen, with currents that can sweep away pontoons, with depths that make anchoring difficult, with a strategic importance that justifies careful planning. The Germans have blown most of the Rhine bridges in their retreat, assuming that even if the Americans eventually cross, the delay will buy time to establish new defensive lines, to bring up reserves, to prepare for a coherent defense. The capture of the Ludendorff Bridge is a disaster, but it is a damaged bridge, visibly sagging, clearly temporary. The Germans believe they have time. They are wrong. At 4:15 p.m., less than 30 minutes after receiving his orders, Colonel Fraser's engineers are already unloading pontoons from trucks, hauling them on rollers toward the water's edge. The pontoons are pneumatic rubber floats, each 33 feet long, awkward and heavy, requiring teams of men to maneuver. The plan calls for anchoring these pontoons in the river current, linking them with steel treadway sections to create a roadway, building the bridge in segments that extend from the west bank toward the island in the middle of the Rhine. It is not elegant engineering. The pontoon bridge is essentially a floating road, held in place by anchors and cables, swaying with the current, vulnerable to artillery and air attack, but is fast. An experienced engineer battalion can assemble a pontoon bridge at a rate of 100 feet per hour under good conditions. Fraser intends to exceed that rate because the conditions are terrible and getting worse. At 4:40 p.m., German artillery opens fire. The first shells land in the water 50 yards short of the American positions, geysers of white foam erupting from the dark river. The German gunners on the heights have excellent observation of the west bank and the river approaches. They can see the American engineers clearly, small figures hauling equipment, working in teams to maneuver pontoons into the water. The German fire is not suppressive or harassing. It is aimed fire, adjusting with each salvo, walking closer to the American work parties. By 5 p.m., shells are landing within yards of the engineers. Men dive for cover behind trucks, behind pontoons, behind anything that might offer protection from shrapnel. The protocol in engineering manuals calls for halting work under direct artillery fire, for waiting until counter-battery fire silences the enemy guns or air support neutralizes the threat. Colonel Fraser does not halt work. He orders his men to keep building. This decision seems suicidal. Artillery fire on an exposed riverbank is among the most dangerous situations an infantry soldier can face. There is no cover, no trenches, nowhere to hide except the water itself. But Fraser has calculated a different risk equation. Every hour the bridge remains unbuilt is an hour that thousands of American troops on the East Bank depend on a single damage span that could collapse at any moment. The tactical situation is desperate. The Ludendorff Bridge is so unstable that only one vehicle at a time is allowed to cross, creating bottlenecks that limit the flow of reinforcements and supplies to the bridgehead. If the bridge falls before a replacement is ready, the entire force across the Rhine will be isolated, vulnerable to German counterattack, possibly destroyed. Against that catastrophic risk, the danger of building under fire seems acceptable. So the work continues. The German observers, watching through binoculars and range-finding scopes from their elevated positions, cannot believe what they are seeing. American soldiers are working in the open, hauling pontoons, driving anchor piles, assembling treadway sections, while shells explode among them. Men are killed. A direct hit on a pontoon team sends bodies tumbling into the water. Another shell detonates near a work crew, and 3 men are down, medics rushing forward. But the work does not stop. New crews replace the casualties. The pontoons keep moving toward the water. To the German gunners, This appears to be either fanaticism or insanity, a disregard for casualties that seems almost Soviet in its ruthlessness. But it is neither. It is calculation, the cold arithmetic of military necessity executed by men who understand that the mission is more important than individual survival, that the bridge must be built even if the cost is high. By 6:30 p.m., as daylight begins to fade, the first section of the pontoon bridge extends 100 feet from the west bank. The pontoons are anchored in the current, the steel treadway sections bolted into place, creating a floating roadway that rises and falls with the river swell. German artillery continues to fire, but the American counter-battery guns have now ranged in on the German positions, and the incoming fire becomes less accurate, more sporadic. The German gunners are being suppressed, forced to fire and displace, unable to observe fall of shot as carefully. This gives the engineers brief windows of relative safety, moments when work can proceed faster. They exploit every minute of reduced fire, racing to extend the bridge another few feet, another pontoon, another treadway section. The rhythm becomes a contest. Work until the shells come close, take cover, wait for the barrage to slacken, resume work. It is exhausting, nerve-shredding labor, but it is producing results. At 8 p.m., with darkness now complete, work lights are brought forward. This is another violation of standard doctrine. Work lights make perfect aiming points for enemy artillery, but without them, the technical work of aligning pontoons and bolting treadway sections is impossible. The lights go on, harsh white illumination spilling across the riverbank, reflecting off the black water, creating a stage where the American engineers perform their improbable construction project under the eyes of the German army. The shelling intensifies immediately. The Germans can see the work site perfectly, can adjust fire with precision. Shells bracket the lights, trying to knock them out, trying to hit the concentrations of men working around them. The engineers keep the lights on and keep working. What the German observers cannot fully understand, what seems incomprehensible from their perspective, is the system behind the apparent chaos. The American engineers are not simply brave men working recklessly under fire. They are executing a carefully rehearsed process, a standardized procedure practiced dozens of times in training, refined through repetition until every man knows his role, every movement is efficient. The M2 treadway bridge system is designed for exactly this kind of rapid deployment. The pontoons are identical, interchangeable. The treadway sections are prefabricated steel, each weighing 1,500 pounds, but designed to be handled by a six-man team. The anchors, cables, and bolts are all standardized. No special tools required, no custom fitting. The entire system is an expression of American mass production philosophy. Make components simple, make them identical, make them in vast quantities, and train your men to assemble them quickly under any conditions. By midnight, the bridge extends 300 feet from the west bank, a quarter of the distance to the island. Casualties are mounting, 8 men dead, 23 wounded, but the battalion has rotated fresh crews forward, and the work tempo has not slackened. Supply trucks keep arriving with more pontoons, more treadway sections, more anchor cables. The logistics are as impressive as the construction. To build a 1,200-foot bridge requires hundreds of pontoons, tons of steel treadway, thousands of bolts and cables, and all of it must be transported to the front, organized, and delivered to work crews in the correct sequence. The American supply system, that vast machine of trucks and depots and transportation corps, is functioning with relentless efficiency, feeding the bridge construction like a conveyor belt, ensuring that materials arrive as needed, that nothing stops for lack of supplies. This is the industrial war in miniature. Not individual heroism, but mass coordination. Not genius, but system. Not one brilliant effort, but the sustained application of resources and organization. At 2 a.m. on March 8th, German bombers arrive, twin-engine Junkers, 88s tasked with destroying the bridges at Remagen. The Luftwaffe is a shadow of what it was, starved of fuel, its experienced pilots dead, its aircraft outnumbered 10-1 by American fighters. But it can still strike at night, and the bridges at Remagen are the highest priority targets in the entire theater. The bombers come in low over the river, and the night explodes with anti-aircraft fire. American 40mm Bofors guns hammer tracers into the sky, the shells rising like strings of red pearls, converging on the German aircraft. One bomber is hit, its engine erupting in flame, cartwheeling into the river with a tremendous splash. The others drop their bombs hastily and flee. Most of the bombs miss, falling into the river or overshooting the bridges, but one strikes near the pontoon bridge construction site. The explosion sending a geyser of water and mud 50 feet into the air, capsizing 2 pontoons and killing 4 engineers. The damaged section is pushed aside, new pontoons are brought forward, and the work continues. By dawn on March 8th, the bridge has reached the midpoint island, 600 feet of floating roadway, now extending across the Rhine. The progress is astounding. 600 feet in less than 15 hours, under artillery fire, under air attack, in darkness. German engineering officers, when they later learn of this, refuse to believe the reports. A 1,200-foot tactical bridge, built in combat conditions, in less than a day? It is impossible. Their own manuals specify that such a bridge would require 3 to 5 days of work by a full engineer battalion under ideal conditions. The Americans are doing it in a fraction of the time, under fire, without halting for casualties or darkness or enemy action. The reports must be exaggerated, the product of confusion or propaganda. But the reports are accurate. What the German officers do not account for, what their doctrine and training have not prepared them to understand, is the American approach to military engineering. Speed over perfection, standardization over craftsmanship, mass production over artisanal quality. A German pontoon bridge is built to exacting specifications, each pontoon carefully positioned, each connection inspected, the entire structure treated as a work of engineering that should function flawlessly. An American pontoon bridge is built to minimum acceptable standards, good enough to bear the load, good enough to last as long as needed, and if it fails, another will be built. This is not carelessness. The American engineers are skilled, professional, and take pride in their work, but it is a different set of priorities. The German standard is excellence. The American standard is sufficiency at speed. In the context of the Remagen bridgehead, where time is the most critical resource, the American approach is devastatingly effective. By noon on March 8th, the second section of the bridge, from the midpoint island to the east bank, is half complete. The work on this section proceeds faster because the island provides some cover from German artillery, and the American presence on the east bank has expanded, pushing the German observation posts farther back. The shelling continues, but is less accurate. The German gunners now firing at map coordinates rather than observed targets. The engineers, exhausted from working through the night, are supplemented by additional battalions brought forward. The work becomes an assembly line. One crew positions pontoons, another crew secures anchors, a third crew bolts down treadway sections, a fourth crew installs safety cables. Each team focuses on its specific task, moving down the line of the bridge as it extends. It is not glorious work. It is repetitive, physically demanding, done in mud and cold water, with hands numb and backs aching. But it is inexorable. At 4:15 p.m. on March 8th, exactly 24 hours after Colonel Fraser received his orders, the pontoon bridge is complete. 1,200 feet of floating roadway, stretching from the west bank of the Rhine to the east bank, swaying gently with the current, guarded by anti-aircraft guns and shrouded in smoke screens to obscure it from German observation. A jeep is driven across as the first test. The bridge holds, then a truck, then a Sherman tank, its 33 tons pressing the pontoons deep into the water, the entire structure flexing and groaning, but holding firm. Within an hour, a steady stream of vehicles is crossing, a parallel supply line to the damaged Ludendorff Bridge, doubling the flow of men and equipment into the bridgehead. The engineers, many of them so exhausted they can barely stand, watch the traffic roll across their bridge and know they have accomplished something extraordinary. 10 days later, on March 17th, the Ludendorff Bridge collapses. The damaged structure, stressed beyond its limits by the constant traffic and the earlier demolition attempts, finally fails. The iron trusses buckle, and the entire central span drops into the Rhine with a roar of tearing metal. 28 American engineers working on repairs are killed in the collapse, crushed or drowned when the bridge falls. But by this point, the loss is tragic but not catastrophic. The pontoon bridge built by Fraser's battalion is still operational, supplemented now by 2 additional pontoon bridges and a heavy treadway bridge. The Americans have 4 bridges across the Rhine at Remagen, pumping divisions across the river at a rate the Germans cannot contain. The bridgehead expands rapidly, a lodgment that will become the spearhead for the final push into Germany. The strategic significance of the Remagen crossing cannot be overstated. It shortens the war, perhaps by months, by placing Allied forces across the Rhine weeks ahead of schedule, forcing the Germans to divert resources from other fronts, creating a breach in the defensive lines that will never be sealed. German commanders, analyzing the Remagen disaster in the weeks that follow, struggle to explain how the Americans built bridges so quickly. Some attribute it to superior numbers. The Americans simply threw more men at the problem. But the engineer battalions at Remagen were not unusually large, and the German engineer units, man for man, are just as capable. Others suggest the Americans must have used some new technology, some secret bridging system. But the M2 Treadway Bridge is not secret or revolutionary. It is simply well designed for rapid deployment, a refinement of existing technology rather than an innovation. The real answer is harder for the German command to accept. The Americans built bridges faster because their entire system, doctrine, training, logistics, industrial production, was optimized for speed and scale in a way that German engineering, for all its excellence, was not. This is the deeper truth revealed at Remagen, the truth that makes German observers shock understandable. German military culture values thoroughness, precision, adherence to proper procedure. These are virtues, and they produce excellent results in contexts where quality matters more than speed. A German tank, a German machine gun, a German artillery piece is typically superior in design and manufacture to its American equivalent, better engineered, more reliable, more carefully made. But the American equivalents are produced in vastly greater quantities, deployed more rapidly, and are good enough to win. The German MG-42 machine gun is arguably the best such weapon of the war, but American factories produce 10 times as many M1919 machine guns, and 10 adequate weapons beat one excellent weapon. The same principle applies to engineering. A German bridge might be better built, but an American bridge built in a quarter of the time is more useful. The symbolic object recurring through this story is not a weapon, but a tool. The pneumatic pontoon, that awkward rubber float that forms the foundation of the American bridge. Each pontoon is unremarkable, mass-produced, identical to thousands of others. Each one, alone, is useless. It is simply a rubber bladder filled with air, bobbing on the water. But linked together in sufficient numbers, anchored properly, supporting steel treadway sections, these mundane objects become a bridge, a lifeline, a highway for armies. The pontoon is the perfect symbol for American military power, not exceptional individually, but devastating in aggregate. The German approach to river crossing involves careful planning, optimal positioning, each element precisely placed. The American approach is to dump hundreds of pontoons into the river, connect them as fast as possible, and accept that the result will be imperfect but functional. The elegance is in the system, not the components. American soldiers, working on the Remagen bridges, experience this at a visceral level. They are not building a monument to engineering excellence. They are building something that needs to work right now, that needs to bear tanks and trucks and artillery pieces until the next river crossing, and then can be disassembled and used again somewhere else. There is no expectation that their bridge will last years or even months. It needs to last weeks, maybe days. This is disposable engineering, temporary infrastructure, the military equivalent of a prefabricated house. To European sensibilities, trained to think of bridges as permanent structures, monuments of stone and steel that endure for generations, the American pontoon bridge seems almost contemptuous of tradition. It is a bridge that acknowledges its own impermanence, that exists only to serve an immediate need. But in war, immediate needs are the only needs that matter. The German defenders, those who survive the Remagen bridgehead, carry with them a memory that will shape their understanding of the American enemy. Many German soldiers in 1945 still hold to the belief that the Wehrmacht is superior in training, in tactics, in fighting spirit, and that Germany is losing the war only because it is outnumbered, fighting on too many fronts, overwhelmed by material superiority. The myth of German qualitative superiority persists even as the Reich collapses. But at Remagen, German soldiers witness something that challenges this narrative. They watch American engineers work through artillery barges that would force German units to halt. They watch bridges rise from the river in time frames that German doctrine says are impossible. They watch an army that seems to operate by different rules, an army where losses are replaced immediately, where damaged equipment is discarded and new equipment appears, where the answer to every obstacle is not careful planning but overwhelming force applied rapidly. This is not to say the German soldiers lose respect for their own abilities or suddenly regard Americans as supermen. German combat units, even in 1945, often fight with skill and determination. But there is a dawning recognition that skill and determination are not enough, that the Americans have advantages that go beyond numbers, advantages rooted in industrial capacity, in organizational systems, in a cultural willingness to prioritize speed and pragmatism over perfection. A German officer, captured at Remagen and interrogated, reportedly says, "You Americans do not fight like soldiers. You fight like engineers and factory workers. You build your way to victory." It is meant as a criticism, a suggestion that American methods lack honor or martial virtue. But it is also an acknowledgement of effectiveness. The Americans do fight like engineers and factory workers, and in industrial warfare, that is exactly the right way to fight. The transformation this produces in American self-perception is more subtle. The soldiers and engineers who build the Remagen bridges do not think of themselves as representatives of a superior system. They think of themselves as men doing a job, following orders, try to stay alive, and get the bridge built. But collectively, these experiences accumulate into a narrative about American pragmatism, American ingenuity, American capability. The ability to build a bridge under fire becomes, in post-war memory, a symbol of American competence, of the can-do spirit, of the idea that Americans can overcome obstacles through hard work and clever solutions. It feeds into a national mythology about American exceptionalism, about the United States as a nation of problem solvers, practical people unburdened by old European traditions, willing to improvise and adapt. This mythology is not entirely false, but it is incomplete. The bridges at Remagen are not built by lone pioneers or rugged individualists. They are built by men following standardized procedures, using mass-produced equipment, supported by a vast logistics network, trained in a military system that emphasizes conformity and adherence to doctrine. The genius, if there is genius, is in the system, not the individuals. The system allows rapid training of competent engineers from civilian workers. The system produces reliable, standardized equipment in enormous quantities. The system moves supplies to the front without interruption. The system absorbs casualties and replaces them without halting operations. This is not the American individualism of frontier mythology, but the American organizational capacity of the industrial age. The same capacity that built transcontinental railroads, that produced millions of automobiles, that churned out Liberty ships faster than U-boats could sink them. The German military, by contrast, is the product of a different tradition, one that emphasizes hierarchy, expertise, and the cultivation of professional excellence. German officer training is rigorous and lengthy, producing commanders who are tactically brilliant and operationally skilled. German non-commissioned officers are career professionals. men who have spent decades in the army, masters of their craft. This produces a highly capable force at the unit level, but it is not a system designed for mass mobilization or rapid expansion. The German army in 1945 is stretched thin, its units under strength, its replacements inadequately trained, because the system cannot produce soldiers and officers fast enough to replace losses. The American army, by contrast, has mastered mass production of soldiers just as it mastered mass production of weapons. The training is shorter, less thorough, but sufficient. The replacements arrive in endless streams, raw but adequate. The system values quantity and speed over individual excellence, and in a war of attrition, quantity wins. At Remagen, this difference plays out in microcosm. The German defenders are skilled, determined, and tactically competent. They use what resources they have, artillery, airstrikes, snipers, to disrupt the American bridge construction. Under normal circumstances, their efforts would succeed, or at least delay the Americans significantly. But the Americans do not operate under normal circumstances. They have enough engineers to rotate fresh crews forward when casualties occur. They have enough pontoons and equipment to replace damaged sections immediately. They have enough supply trucks to keep materials flowing without interruption. They have enough artillery and anti-aircraft guns to suppress German fire enough to allow work to continue. At every level, the American response to German action is more men, more equipment, more firepower. It is not subtle, not elegant, but it is effective. The pneumatic pontoons bob and sway in the Rhine current, linked together by steel and cables, flexing with every vehicle that crosses, rising and falling with the river's flow. They are not beautiful. They are not permanent, but they are sufficient. They do the job, and in doing the job, they embody a truth about the American way of war in 1945, that sufficiency, deployed at scale and speed, beats excellence that arrives too late or in too little quantity. The German defenders at Remagen are fighting with a 19th century mindset in a 20th century war, still believing that quality and skill are the decisive factors. The Americans have already moved to a paradigm where logistics and industrial output matter more than individual or unit-level superiority. As the months pass and the war grinds to its conclusion, the bridges at Remagen become part of the legend of the Allied advance, symbolic of the moment when the last great barrier to invading Germany was overcome. But the real significance is not the Rhine crossing itself. Other crossings would have been made, other bridges built, even without Remagen. The significance is in how it was done, the speed and determination and systematic efficiency with which American engineers turned an impossible task into a completed project in less than 24 hours. It is a demonstration of capability that shocks the German command because it reveals the full extent of the gap between the two sides, not in courage or training, but in systems, in organizational capacity, in the ability to mobilize and apply resources rapidly. Years after the war, military historians will study the Remagen crossing, analyzing the tactics and decisions, debating whether the bridgehead shortened the war significantly or merely accelerated an inevitable conclusion. But for the men who were there, for the engineers who worked through the night under shell fire, for the German soldiers who watched in disbelief as bridges rose from the river in hours instead of days, the experience is more immediate, more personal. It is the memory of doing something that seemed impossible, of watching your enemy do something that should not have been possible, of the moment when abstract concepts like industrial superiority and logistical advantage become concrete, visible, undeniable. The Rhine at Remagen flows on, dark and swift, indifferent to the history made on its banks. The pontoon bridges are long gone, dismantled when no longer needed, their components reused elsewhere or scrapped. The island where the midpoint anchors were secured is quiet now, visited by tourists who come to see the remnants of the Ludendorff Bridge towers, preserved as a memorial. The river gives no sign of the urgency and violence that unfolded here in March 1945, no marker for the spot where men died building a bridge under fire, where engineers accomplished in one day what doctrine said should take 5. But the legacy endures in the archives, in the after-action reports that document every detail of the bridge construction, in the photographs that show pontoons being manhandled into position while shell splashes erupt nearby, in the casualty lists that record the names of men who were killed so that tanks could cross a river. The legacy endures in the institutional memory of military engineering, in the doctrine that evolved from Remagen's lessons, in the continued emphasis on rapid deployment and standardized systems. The legacy endures in the broader narrative of how the Second World War was won, not primarily through battlefield heroics or tactical brilliance, though those mattered, but through the unglamorous work of logistics, engineering, production, the systematic application of overwhelming resources. The pneumatic pontoon, that humble symbol, that mass-produced rubber bladder, represents a truth about democracy and industrial society that goes beyond military engineering. It represents the power of the collective, the strength that comes from standardization and mass participation. The idea that ordinary components, ordinary people, organized into effective systems, can achieve extraordinary results. The German military culture valorizes the exceptional individual, the ace pilot, the brilliant tactician, the elite unit. This produces real excellence, real capability. But it is a model that does not scale, that cannot replace losses fast enough, that depends on excellence being distributed throughout the force. The American model valorizes the system, the standardized procedure, the adequate component produced in enormous quantity. It is less romantic, less individually heroic, but it is scalable. It is sustainable. It wins. At Remagen, when the first tank crossed the pontoon bridge that was built in a day, under fire, in conditions that should have made construction impossible, that tank was not crossing merely a bridge. It was crossing a divide between two philosophies of war, two approaches to organizing human effort, two visions of how capability is generated. The German defenders, watching from their crumbling positions, seeing the endless stream of American vehicles pouring across the Rhine on bridges that should not exist, confronted the reality that their side had lost not because they lacked courage or skill, but because they were fighting an enemy that operated on a different scale, with different rules, with an abundance of resources and a ruthless efficiency in applying them. And in that abundance, in that systematic efficiency, in those bobbing pontoons linking shore to shore, there is a larger story about the nature of freedom and democracy in industrial age. Not freedom as abstract rights or political philosophy, but freedom as material reality, as the productive capacity that comes from mobilizing an entire society, as the innovation that emerges when engineers and workers are trained to think for themselves, to improvise solutions, to question inefficient procedures. The bridges at Remagen are not monuments to American individualism, but to American organizational capacity, to the strength of systems that can harness individual effort into collective achievement. They are symbols of a democratic industrial society at full mobilization, where the son of an Iowa farmer and the grandson of an Italian immigrant work side by side assembling pontoons, where factories in Michigan and Pennsylvania produce the equipment they use, where the entire apparatus of a continental nation focuses on a single goal: victory, achieved not through brilliance, but through weight, not through excellence, but through sufficiency multiplied 1,000-fold. The Rhine flows dark and cold beneath the stars, and on its surface, floating on compressed air and rubber and American ingenuity, a bridge carries an army into the heart of the Reich, built in a day, built under fire, built because it had to be built and because the men who built it believed it could be done. The shock of the German defenders is not merely tactical surprise, but existential recognition. They're facing an enemy that does not accept limitations, that respond to obstacles not with careful planning, but with overwhelming effort, that builds bridges and time frames that make traditional doctrine obsolete. It is the shock of meeting an opponent who fights by different rules, who has rewritten the equation of what is possible through the simple expedient of bringing more of everything. More men, more equipment, more determination to get the job done regardless of cost. And when the last vehicle crosses, When the engineers finally stand down and the exhausted men collapse on the riverbank, they have built more than a bridge. They have built a demonstration, a proof, a symbol of what their nation can do when necessity demands it. They have built a monument to sufficiency, to standardization, to the unglamorous power of doing adequate things at overwhelming scale. They have built in steel and rubber and sweat a chapter of the final argument about how this war would end, not with a decisive battle of maneuver, not with tactical genius, but with bridges rising from rivers under fire, with tanks rolling across impossible spans, with the weight of an industrial democracy grinding forward, inevitable as the current of the Rhine itself.